In this lesson, we are going to learn how to find equations for a line in space. So from this figure that I have here, okay, we have a line drawn in red. Okay, so let's name this line here L. Okay, and then we have a vector V here which is parallel to the line L. And we have the line L passing through point P. Okay, and then you have point Q here which is also on the line L. So you see that this vector here is parallel to the line L here. Okay, so what then happens is that if I generate a vector on the line L, which will be taken as vector PQ. Okay, if I generate a vector PQ here, this vector here will be parallel to V because that vector will be on the line, and then the line is already parallel to the vector V. So the vector PQ will be equal to some scalar T multiplying the vector V. Okay, where this vector V here will be the direction for that will be the direction vector for vector PQ. Okay, so let's take note of this. So this vector PQ here is on this line here. Okay, and we can find vector PQ by subtracting the component of point P from that of what? Point Q. Okay, so we are going to consider P and Q as vectors. Okay, that's as position vectors. So we are going to have vector PQ to be x, y, z, okay, minus x naught, y naught, z naught. Okay, this should be equal to the scalar T times vector V, which has components A, B, and then C. Okay, so this is what you have now. So I'm going to rewrite this by taking this term here to the right hand side. Okay, so I'm going to have x, y, z, okay, to be equal to x naught, y naught, z naught, okay, plus t multiplying vector v, that's a, b, and then c. Okay, so this is what we have now. Okay, so let's name this equation here as equation 1 and then this equation as equation 2. Okay, this equation 2 here is known as the vector equation of a line. Okay, this equation is known as the vector equation of a line. So what I'll do is that I will let r be equal to x, y, and then z. Okay, and then I'll let r naught be equal to x naught, y naught, then z naught. Okay, so let's do the substitution. So I'm going to have equation 2 to be r equals r naught, okay, plus t multiplying v. Okay, so this will be the vector equation of the line now. Okay, so let's name this as equation 3. Okay, let me circle this. Okay, let me draw this rectangle around this equation. Okay, so we have this equation now. So what we are going to do next is that we are going to consider equation 2. Okay, and then equate components. Okay, so let's look at what I'm going to do now. So I'm going to have, that's from equation 2, I'm going to have x to be equal to x naught plus ta. Okay, I'm multiplying the scalar by the component of vector v. I'm going to have ta. Okay, the a is too big. And then we are going to have y to be equal to y naught plus tb. And then I'm going to have z to be equal to z naught plus tc. Okay, so what you have here now will be the parametric equations of the line. Okay, so these equations will be known as the parametric equations. Parametric equations. Okay, so now let's look at what you are going to do. So from these parametric equations here, I'm going to solve for the scalar t in each one of them. Okay, so for the first equation, you're going to have x minus x naught divided by a. Okay, that would be equal to t. You're going to have y minus y naught divided by b. Okay, and then this will be equal to t, and then you have z minus z naught divided by c to be equal to t. So from what we have here, you see that they are all equal to the scalar t, so which means that all these equations are the same. So we are going to have x minus x naught divided by a to be equal to y minus y naught divided by b, okay, to be equal to z minus z naught divided by c. Okay, this equation is known as the symmetric equation. So let's let me draw a rectangle around this. That's the parametric equation. Okay, we are going to need them to solve examples, and then have the symmetric equations to here. Okay, so now we know the vector equation, okay, which is what we have here. This is the vector equation. And then we know the expression for the parametric equations, and then we know the symmetric equations also. So with this knowledge, we are going to try our hands on an example for a better understanding. So let's look at that. Okay, so given that R naught, okay, equals 1, 2, and then 0, and then V is given to be 1 minus 3 and then 2. Okay, and then I asked that I should find the vector equation, okay, using these two vectors given. How is it going to be? So now all we have to do is to consider this equation here, okay, which is equation 3, given to be R equals R naught plus TV. Okay, this is what you have now. So let's do the substitution. You're going to have R to be equal to 1, 2, 0, okay, plus T multiplying 1 minus 3, 2. Okay, this is what we have now. Okay, so what I'll do is that we can further simplify this vector equation here, right? So this will give us R to be equal to 1 plus T, okay, comma 2 minus 3T, comma 0 plus 2T. Okay, this is what we are going to have. So this will give us, you can further simplify this because of this 0 here, okay, but you can choose not to write a 0. So I'm going to have this R here to be equal to 1 plus T, comma 2 minus 3T, comma 2T. Okay, so this will be our vector equation now. Okay, let's try our hands on another example. Okay, so I have another example here which says that we should find the parametric and symmetric equations of the line passing through points 1, 4, minus 2, and then minus 3, 5, and then 0. So I have to find the parametric equations and then symmetric equations of the line passing through these 2 points here. So when you look at the parametric equations that we have here, okay, this expression and then this expression here, okay, you will see these points A, B, and then C in these two equations. Okay, so for us to be able to find the parametric equations and symmetric equations using these 2 points here, we must find A, B, and C, which are the components of the vector V. Okay, so let's look at how you're going to find this. You know vector v here is the direction vector. Okay, so to find this direction vector, we can subtract this point here, this first point here from the second point. Okay, so I'm going to name this first point P and then the second point Q. Okay, so we're going to have in this case V to be equal to PQ, right? Okay, that's to be equal to vector PQ. So to find V here, I'm just going to subtract the component of P from that of what Q, right? So we're going to have minus 3 minus 1, okay, comma 5 minus 4, comma 0 minus 2. Okay, so this is what we are going to have. So when I simplify this, I'm going to have V to be equal to minus 4, comma 1, and then comma 2. Okay, so to find the direction vector, all you have to do is to subtract the initial point from the final point. Okay, so I used P as the initial point and then Q as the final point, and then I found the vector V. Okay, so that's what I did now. So we now know V. Okay, so from here we can take A to be equal to minus 4, we can take B to be equal to 1, and then C to be equal to 2. So now to find the parametric equations, I'm going to consider this equation here. Okay, so we have x equals x naught plus ta. So for x naught, y naught, and z naught, those are the points. Okay, so you can consider point P or consider point Q. When you consider point P, you must use only the component of P, and then when you consider point Q, you must use only the component of what Q. So in this case, I'm going to use point P here, which is the first point. Okay, so we are going to have for the parametric equations, you're going to have the first one to be x equals x naught. Okay, so in this case, x naught will be 1. Okay, which is this one here because I'm considering point P. Okay, which will be 1 plus ta. Right, so that's plus t multiplying a, which is what minus 4. Right, so this is going to give us s to be equal to 1 minus 4t. Right, so that'll be the first parametric equation. So let's find for the second one, which is y equals y naught plus tb. Okay, we know y naught to be equal to 4 because we are considering point P. So we are going to have y to be equal to 4 plus tb. Okay, that's t multiplying b, which is what 1. So I'm going to have y to be equal to 4 plus t. That'll be the second parametric equation. Okay, and then for the third one, we're going to have z to be equal to z naught plus cc. Okay, we know c to be equal to 2, and then we know z naught to be minus 2. So z will be equal to minus 2 plus t multiplying 2, that was 2t. Right, so this will be the third parametric equation. Okay, so from here you are going to find the symmetric equations. Okay, we already know the point and then we know the vector component. So for the symmetric equations, you are going to have x minus x naught. Right, we know x naught to be 1, so that will be x minus 1 divided by a, which is minus 4. Right, and then this should be equal to y minus y naught, right? So that will be y minus 4. Okay, divided by b, and then you know b to be 1. So this should be equal to z minus z naught. We know z naught to be minus 2, so that is z minus 2. Okay, divided by c, which is 2. Okay, but because of this minus double minus sign there, you are going to have a plus sign there. Okay, so that will be z plus 2, z plus 2.